Hello everyone, and welcome back to the Kohi Game Engine series. Today we are going to focus on enhancing the functionality of our texture maps, and we're going to start preparing things for our view system. So this time we're going to be basically refactoring the way that our samplers work, where those samplers are stored, and make our texture maps do a little bit more than just hold a pointer to a texture. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. So, the biggest issue so far is that we have our sampler being held along with our texture, which served us fine for temporary purposes, but it's not really where it belongs, because you can use a texture in various different ways. Across different texture maps, for example. So you may have different ways that you want to sample it. For example, you may want to use nearest neighbor filtering on one use of the texture. In another place, you might want to use a linear filter mode, for example. And so really where the sampler belongs is as part of the texture map as opposed to the texture. So we're going to be pulling the sampler out of the texture, and we're going to be putting that into the texture map, which means we're going to need a couple more points of entry into our renderer to be able to actually assign these things to the texture map. We're also going to need a way to abstract this from the rest of the engine, so that the rest of the engine doesn't have to be concerned with samplers or how they work under the hood. All we basically do is provide a configuration, toss it over to the backend, and then it gives us what we need. So there are a couple of changes that we need to do to prepare for this first. So I'm going to start with the changes in our resource types, and we're going to make the changes to the texture map first and foremost. And then we'll start making changes to our Vulkan types to move things around a little bit, and then from there we will continue in actually exposing those things to the front end and so forth. So the first place we're going to start is our resource types, and there is actually one field that I want to add to our texture right away, and that is going to be probably right after transparency. We want a flag to indicate if the texture is writable. Now, this is not something we're going to use right away, but we are going to need it coming up soon, so I want to go ahead and get this in there for that. So, the next thing that we need to do is we have some various texture filtering modes that are available. And if you recall our discussion about texture filtering, we basically have linear or what's called nearest neighbor. And the difference between those is one of them gives a very pixelated look and the other sort of smooths out the texture as it's sampled. And so those are modes that are sort of available across various graphics APIs that are agnostic of whether it's Vulkan or OpenGL or DirectX or what have you. And then the second thing that we're going to define is what's known as a texture repeat, which is how the texture tiles when we exceed that 0 to 1 texture map range, or the texture coordinate range, rather. And so there's repeat, which is just you repeat the texture as is. And then you have a mirrored repeat, which is every time you repeat the texture, you mirror it. And then you have clamp to edge, which is basically saying snip it off, and basically repeat the last value of that edge into infinity. And then you also have clamp to border, which takes a border color, which for example could be black, and it says basically once you exceed the ranges of the texture, use black instead. And so those things I'm just going to paste in here because we don't really need to go into writing enumerations sort of live. So we have our texture filter here, which provides our two modes, our nearest and linear. And then we also have the texture repeat, which gives us our texture repeat, mirrored repeat, clamp to edge, and clamp to border. Now, incidentally, these happen to line up with the way that Vulkan does it under the hood. This is not really designed to just be a one-on-one with Vulkan. It just happens to line up in this case. So it's a little bit convenient, but it's not necessarily the way that we're going to design this whole thing. The next thing that we have to do is we have our texture map here, which right now just holds a pointer to a texture, which we're not going to change. And then it also has a texture use, which we're not going to change either. So all we're actually going to do is we are going to add to this. So the first thing that we're going to add is our texture filters, which we need one for minify and one for magnify. So we have the ability to have different filters for those. And then we also have the ability to have a texture repeat. And we're actually going to define this on 3 axes. So we have U, V, and W. You can think of these as sort of the same as X, Y, and Z. The only difference is we typically use U, V, W when we're talking about texture coordinates instead of X, Y, Z. It's just sort of a convention that's followed. We could also use S, T, or U if we really wanted to do that. That's another convention that's commonly used. But in this case, we're going to use U, V, and W. And the last thing that we're going to have is a void pointer to some internal data. And this is going to be the render API specific data that we're going to hold. In our case, the actual sampler, the Vulkan sampler, is going to be held in there. And so that is how we are going to separate that from everything else. So I just want to build this real quick in the hopes that the IntelliSense here fixes itself, and for some reason my highlighting is not working. Let me just reload the window real quick. There we go. Okay. So we've got all that stuff in place. And I did notice another thing in the comment here. We actually have this sort of orphan comment that I forgot to actually remove. So this actually isn't a comment for anything, so I'm just going to go ahead and snip that out of there as well. And that is pretty much it for our resource types. So these are the changes that we needed for that. I think the next thing that I'm going to do is jump into the Vulkan types. So I'll jump to Vulkan types INL. And we're actually going to take a look at the Vulkan texture data. And this is where the sampler is actually being held right now. So I'm going to remove this for right now. And the only thing the Vulkan texture data is going to hold right now is an image. We may be expanding on this at a later date. So I don't necessarily want to nuke this structure just yet. But for now, we just have the image in there because that's really all that we need from a texture at this point. So the next thing that we need to do is we actually need to update our instance state. So we have right here our structure for the Vulkan shader instance state. And right now we are actually holding an array of texture pointers to the instance textures for a Vulkan shader instance state. This is not actually how we want to operate. We don't want to store the textures here anymore. We actually want to keep our texture maps here. So what we're going to do is we're going to change this to texture map, and it is going to be an array of pointers just like we had before. So the structure of it isn't changing. It's just what we're storing there is. And then instead of instance textures, this is going to be instance texture maps. So we'll go ahead and change that. And then we'll go ahead and update this as well. We'll have instance texture map pointers so that our comment is correct as well. And so that is all the updates that we need to our Vulkan types. Okay, so I think probably the next place that makes the most sense to update is probably going to be on the Vulkan backend, and then we'll sort of bubble up the changes to the other areas as we go. So I think probably, in fact, before we do that, let me go into the texture system and fix one thing as well. So where we're creating our default textures, let me go to the actual definition here. Where we're creating our default textures, we actually had added a property to our texture, and that was the isWriteable. And so we actually need to come in here and set that, and it's just going to be false for these textures. So since we added the property, we might as well go ahead and fill it out. So I'm going to set that for the default texture, the default diffuse texture, and the specular texture. And let's just grab this, as well as the default normal texture. All right. And let's see, I think that is all we actually need to do. Let me just double check my notes to make sure I didn't actually miss anything. That is create default textures. Load texture, we're actually going to need to modify that as well. So where we are setting, whenever we're loading a texture, if we're loading a texture this way, it's going to be a read-only texture. So we actually need to set our temp texture is writeable equals false. So that way that property is correctly set everywhere. And we are going to be revisiting writeable textures probably in the next video, but this is just a little sort of prep for that. Okay, so the next thing that I'm going to go ahead and change, I think, like I said, is going to be the Vulkan backend. So let's go to start with Vulkan backend.h. And we're going to find our acquire instance resources. So acquire instance resources. And we're actually going to have to pass one thing in additionally here. So right now we're taking the shader and the out instance ID. And what we're actually going to be doing is we're going to be passing the texture map. And we're going to pass a double pointer called maps. And so whenever we go ahead and acquire our instance resources, we are going to be acquiring our texture map resources for that at the same time. And then, why is that? Boy, IntelliSense is really messing up today for some reason. Let me reload this again. There we go. Okay, so that's our acquire instance resources. However, we also we want to have the ability to acquire texture map resources. And so we're going to add a couple of properties here, or a couple of functions here rather, to acquire map resources. And this is basically what's going to create our samplers within the texture map. So this basically here is going to process those, and this is going to acquire those resources. So we'll see that here in just a second. So actually the next step of this is going to be probably the largest set of changes. So we want Vulkan backend C, and we are going to go to create texture. So we want create texture right here, Vulkan renderer create texture. And towards the bottom of this is where we're actually creating the sampler for the texture. So we don't actually want to do this anymore. We don't want to call the VK create sampler or any of that. So we're actually not going to be doing this anymore as part of the sampler. So we're going to go ahead and remove that because we're going to do that as a separate step now. And by proxy, that also means that whenever we destroy a texture, we're also going to not be destroying a sampler at that point either. So we can see here that we've already got some errors here, so we're actually just going to remove these 2 lines of code that destroys the sampler and sets its data to 0. So we're going to go ahead and kill that. And then we're going to go next to our apply instance, because we're just going to kind of go in order here. Whoops, wrong menu. Apply instance is what I want. There we go. So our apply instance is basically going to now apply our texture maps instead of using a texture. So if we take a look at our loop, let's see, where is that? Here. So we have our loop here that's going over our sampler count. This is what we're actually going to be changing here. So we have a to-do in here that says only update in the list if actually needing an update. We're not going to be solving that right away. We still have to make some other changes before we actually get to this point, but that is coming soon. So right now we're saying texture t is equal to internal instance states for the bound instance ID and then instance textures I. So this is no longer what we want to do. We actually want, instead, we want to say texture map, and we're going to have a pointer, and we're going to call this map. And then we still want internal instance states for the bound instance ID, so that is fine. But here, instead of instance textures, we want instance texture maps sub I. So after that, we can then say texture pointer t equals map texture. So it's sort of one more step that we have to, whoops, I misspelled texture. So it's sort of one more step that we have to do to get that texture pointer, but not a huge deal. So the next thing that we're going to do is instead of internal data sampler, we're actually going to have map internal data. And since that is a void pointer, and this is actually looking for a sampler, let's go ahead and just cast that to vk. Whoops. I apparently can't type tonight. Okay. So instead of pulling that directly from the texture, now we just pull it from the texture map. So that is it for that. The next thing that we're going to need is actually a couple changes to our acquire resources. So we have acquire instance resources. So this is obviously wrong now. So we're going to change this to texture map double pointer maps. And it's a double pointer because remember it's an array of pointers. So we'll go ahead and fix that. But before we can actually fill out the code here, there is something that we're going to need to do in terms of a sort of conversion function. So if you recall before, I talked about we have this sort of configuration for our texture maps, where our texture maps define a repeat mode as well as a filter mode. And we just need to take those sort of generic types that we've created and convert them to Vulkan types. And so this is something that I really don't think is beneficiary to sort of code live, so I'm going to paste this in. And all this does is it takes a texture repeat, it takes a string axis, so that'll be typically X, Y, Z, and that's purely for debugging purposes. And so it basically runs through each case of our texture repeat and says if it's repeat, then we want to go ahead and return sampler address mode repeat. If it's mirrored repeat, we return VK sampler address mode, mirrored repeat, and so on and so forth. So all this does is just a straight conversion. The only reason we take this axis in is purely for debugging. So we have a warning here that says convert repeat type on axis, type X is not supported, and we just spit that out. And then we'll go ahead here and default to sampler address mode repeat in that case. And that's why we're throwing a warning, because we don't want the application to abort. That's kind of stupid. It's just if it's misconfigured, we're just going to choose some reasonable default and proceed with that. So that is for the repeat type. We also need a quick converter for the filter type, which basically does the exact same thing. The only difference here is we take an op, which is whether it's going to be minification or magnification. And then, of course, we take the filter and convert it to a VK filter and just return that. And then we finally get to our acquire instance resources. So, in fact, before we jump to that, let's go ahead and fill out for these guys here. Our texture map acquire resources, because this is actually where we're going to be creating our texture map internal resources, aka the sampler. So I'll go ahead and stub these out. So we have one to acquire resources, one to release resources, and we take a pointer to a map that we're going to be acquiring or releasing the resources for. And basically what we have is we are going to wind up with almost a copy of what we have, what we deleted further up in the file. So what we do here is we create a sampler create info, and we start filling that out. So the difference between this and what we had before is this is much more configurable. So we have our convert filter type for our min and mag filter, and then UVW, we get the repeat types for those that are configurable. And I'm going to put a to-do back here for the rest of these properties being configurable, because we're making some assumptions here about anisotropy that don't necessarily always make sense or might not even be supported. But in this case, we're going to go ahead and just default these things. And so these are all the same defaults that we had before. But I'm putting a to-do here because eventually we want our texture map to be able to configure these things as well. And then this anisotropy will probably be based off of some global property if anisotropy is actually supported, and what level of anisotropy we actually want. Then we can go ahead and configure this off of that. So there's a few different data sources that this stuff is going to be coming from, and we don't have that set up now, so I'm going to leave a to-do configurable there. The next thing is stuff we have seen before. So all we do here is now create our sampler. And the sampler is going to be stored directly in our void pointer for our internal data. And so all we do is we grab the address of that, cast it to a pointer to a VK sampler, and then call VK create sampler, passing our configuration. We go ahead and make sure that that sampler was actually created correctly, and then we return true if it was, or bleat about it and return false if not. Now there's really no reason that a sampler creation should fail, so I'm going to treat that as an error because we can't actually use a texture if its sampler creation has actually failed. So that is much more of a serious issue, so I'll go ahead and treat it as such. Okay, so as you might have surmised, the destruction is actually going to be pretty straightforward. All it does is check to see if we actually pass the map to it, and then calls VK destroy sampler on it, passing the internal data directly, and then it just zeroes out the map internal data. And that is all that this does. So now we have this stuff hooked up so that we can go ahead and pipe this up to the front end here in a few minutes. So now we can actually move on to our shader acquire instances. So basically the idea is at this point our texture maps should already be created and initialized. We should have resources for those things. And so as we actually go to set this up and set up our descriptors, we should already have what we need to set up to do this. So we have a couple of errors in here, and this is because we've changed some code. First, we have our instance textures, so this should be instance texture maps. That would be my cat sneezing in the background. You okay, kitty? Oh, you poor thing. You okay? she has allergies just like me. So she's on medication for it, but unfortunately she has sneezing fits also just like me. Anyway, back to this. So we have our instance state, instance texture maps. So here is where we allocate an array for that. So obviously we need to change this size of texture to size of texture map pointer, which is technically the same thing because it's just the size of a pointer. But just for making things consistent, we're going to go ahead and update that as well. And then what we're going to do here is we're going to set all of our pointers to default until assigned. And so this is just again, changing to texture maps. And then we need, instead of assigning that directly, we're going to point to the texture and set that to the default texture. And I believe we actually need to, let's see, we have our texture count. Oh, right, we actually need to, we need to set this because we haven't actually set this yet. So we've created our array here, but we haven't actually set it. So this would fail if we didn't do that. So actually, I'm just going to copy this part right here. So we're going to say our texture maps, our instance texture maps, sub I equals maps sub I. And so it's basically just going to pull from this array of texture maps here. So it's going to keep a pointer to the texture map, and then we'll go ahead and assign the default texture of that texture map to our default texture that we get here, just to make sure that we have something that's there until we actually load up a legitimate texture for it. Okay, so the next thing that we have, I believe, is a little bit further down. And this is going to be in our release. So again, that is just going to be a simple matter of changing this to texture maps. And then we are going to free the texture maps because we no longer need that array anymore. Again, I'm just going to change this for the sake of continuity and keeping things consistent. And then we'll go ahead and set that to 0. So that is where we go ahead and free our array of texture maps. And then let's see. So we have that. We also, I believe, are going to need an update, yes, to set uniform. So our uniform, if we are actually setting a sampler right here, instead of dealing with the texture itself, we also have to point to the texture map at the uniform location and then use the texture of that. So we just need to change that instead. And let's see. That is global texture maps. This also has to be changed. So our instance, let's see. Let me just double check that I didn't just update the, yeah, okay. So that is actually one thing that it looks like I forgot to change. So our global textures right now is just a texture array, or an array of texture pointers. That is actually wrong as well. So in our shader system, we're actually going to have to update that as well. That should be an array of texture map pointers. So we need to rename that as well to global texture maps. So when we come back here, we should have global texture maps. And then in this case, we should have a texture map value. So whenever we set that, I believe that is what we're going to need to do there. That might not actually be right. No, that should be just the texture pointer as well we had before. It should be texture. Right, okay. So our global ones and our instance ones here are updated accordingly. So that, I believe, should be everything that we need to do in the Vulkan backend. So not a terrible amount of changes there, but it kind of cascades out a little bit in terms of what we need to actually do. So we also have to make some additional updates to our shader system, but I think I'm going to hold off on that until we actually bubble these changes up to our front end. So I think that is going to be the next thing that I do. So we actually need to start at renderer types INL, and we're going to first, let's see, probably also going to need to do acquire instance resources. Here we go. So we're going to need to add another parameter here. This is going to be texture map. And again, this is an array of pointers. We're going to call that maps, which means that we have a new param here. So we'll call this maps, and we'll just say an array of pointers to texture maps must be one map per instance texture. Okay, so in other words, for each configured sampler that we have in our shader, we have to have a texture map for each one of those, which makes sense when you think about it. The other thing that we're going to need to do is we are going to need to come down here and add a couple of function pointers. So we are actually going to need one for our acquire resources and one for our release resources. I don't feel like typing all that out, so I'm going to paste it. And so what we're dealing with here is basically two new function pointers that point to our code in the back end. So that is actually all we need to do for our renderer types. So now that we have that, we can actually hook this up on the front end. So let's go ahead and go to frontend.h. And we'll go ahead and go to first our acquire instance resources. We'll go ahead and add our texture map array of pointers here called maps. And again, we'll actually add this comment here, param maps, an array of texture map pointers must be one per texture in the instance. Sure, that's fine. And then, of course, we need our two methods down here that we added before. So we need our acquire and our release. Again, I'm just going to paste these in because they're the same exact signature as what you guys have already seen. So we have our renderer texture map acquire resources and our renderer texture map release resources. So I'm going to copy these two and go to our renderer frontend.c, go all the way to the bottom, paste these guys in, and we're going to stub out these functions. And while we're in here, we have our renderer shader acquire instance resources. This needs texture map maps, and then we can just pass in maps to the backend. And then here we'll return state pointer backend acquire texture map acquire resources, and we'll just go ahead and pass through the map there. And then here we'll call state pointer backend dot release texture map release resources, and we'll pass through map there. So now that is hooked up from the front end, and that's all we have to do, thankfully. It's just a simple sort of pipe through operation there. And that, before we forget, I should probably also go into renderer backend.c and add our texture pointers for that. So we have our out renderer backend, and we'll say texture map acquire resources equals Vulkan texture map acquire resources, and out render a backend texture map release resources equals Vulkan texture map release resources. Okay, so that way our function pointers are assigned as we would expect. And I think now is probably the time that we would go on to our shader system updates. So our shader system .h, we've already changed this to be an array of texture maps for our global texture maps. And in fact, I think that is actually all we need to do in this file. So I think everything else is actually done in the C file. Yeah. Okay, so, whoops. So we'll go to shader system.c. And I guess we'll sort of do this just in order from top to bottom. So in our shader system create, we're going to need to change this out shader global textures to global texture maps. And this is going to be a DArray create of type texture map pointers. Right, so it's an array of pointers. And then a little bit further down, down here, right before, let's see, do I want to put it there? No. Yeah, we're not going to do it there. Okay, let's go ahead and actually handle the destroy next, I think. So let's see, shader destroy. So what we're going to need to do here is, I think probably right before the name, we're going to have a U32 sampler count. We're going to get the DArray length of S global texture maps, and then for U32I equals 0, I is less than sampler count plus I. And we'll go ahead and free each one of these texture maps. And this will make more sense here in a minute once we actually go ahead and acquire these things. But whenever we actually destroy a shader, we're going to need to free these things. So this is going to be global texture maps sub I. Remember that is a pointer, so it's an array of pointers rather. We want size of texture map, and we're going to use the memory tag renderer for this because it is part of the renderer. Kind of makes sense that would be the case. We're also going to do darray destroy, and we're going to pass S global texture maps to that. So we need to just make sure to clean up our newly created array there, because I don't think we were actually doing that before with our textures because that was owned somewhere else. But now that we actually have an array of our texture maps, we need to actually go ahead and perform this operation here. So the next thing that we need to do is actually go to add sampler. We don't want that definition, we want the actual function definition. So we have down here our global texture count is our DArray length. This is pointing to global textures, which doesn't exist anymore. That's global texture maps. So we go ahead and get that. And then that should actually be, let's see, we have our global textures here. This should be global texture maps as well. And instead of actually pushing, you know what, actually this line of code is wrong because that's pushing a default texture. We don't want to actually do that at all anymore. What we actually want to do is create a default texture map when we're adding the sampler. So we're going to sort of create a map with some defaults, and then if for some reason we have something to override that later, we can go ahead and do that. But for now, we're just going to create some defaults. So I'm actually just going to put a note in here and say creating a default texture map to be used here can always be updated later. And so let's go ahead and create a texture map, and we're going to call this, unsurprisingly, default map, and we're just going to initialize that with all the zeros, and then we'll say default map, and then we'll say filter. Let's do magnify first, sure. Text filter, and we want linear by default, and I'm just going to copy and paste to this. And we want filter minify, and that's also going to use the same filter for that. And then we're going to set the default map dot repeat u, and we're going to set that equal to repeat v and repeat w, and we're going to set all three of those basically at once to texture repeat. And that's just sort of a sane default to use. Default map. We're also going to set the use to text use unknown, because we don't know how it's really going to be used right off the bat. And then what we're going to do is we're going to here call renderer text map acquire resources, and this is where we're actually going to acquire our sampler at this point. And so we're going to pass the address of default map right there, and that is going to go ahead and fill out the internal data of that texture map. And if actually that does not succeed, we are going to say k error failed. Whoops! Wow, I cannot type tonight. Failed to acquire resources for global texture map during shader creation. And then we're going to return false, because that is bad, and we do not want to operate off of that, because that's just going to cause Vulkan to crash. So if we get this far and it fails, we just want to sort of abort out at that point. So the next thing that we want to do is we want to go ahead and acquire a pointer. We'll call this map for now, actually, this map. And we'll do that by calling kallocate. And this is going to be size of texture map. And we're going to say memory tag, tag renderer, as we did in the destroy. So we're going to go ahead and do that, and we're going to set the reference of, or the value of map by dereferencing map to default map. Okay, and then we will set map texture equal to texture system get default texture. And then finally, we can call our darray push. And we can push this to shader, global texture maps, and we're going to push map. So at this point, we've gone ahead and created this. We allocate this here because we want to make sure that we don't go out of scope and lose it. So we're just using an allocation there to ensure that, because we want to work with an array of pointers, and this is sort of the way that we're doing it for now. I may wind up actually changing this later, but for now, I'm just going to put in allocate a pointer, assign the texture, and push into global texture maps. And then we should also note here, this allocation is only done for global texture maps. So we're only doing this for globals, which is why I think it's fine to do it this way. Again, we may optimize this later, but for now we're just trying to get this to work. So that is really all we need to do in our shader system. I think we should be good to go there. So we've done the header file for that already. I think the last thing that we actually need to do is to update our material system. So let's open up our material system, and I think we only actually need to change stuff in the C file. I don't think there's anything in the header file that we need to change. So the first thing that we're going to want to do is go into our apply instance, because we're going to have to make a couple of changes in here. So let me just double check my notes here. So before, what we were doing was we were setting the uniform by index, and we were passing through the specular map, diffuse map, and normal map textures, and actually am I just missing something here, or are we actually doing the specular texture twice? So we have our diffuse texture, our specular texture we're doing twice. We're actually passing this through twice. And then our normal texture. Yeah, I don't know why we're doing that. I must have copy-pasted that somehow, because we should only have these three. Okay. So anyway, instead of passing the diffuse map texture, or the specular map texture, or the normal map texture, we're actually just going to pass the address of these maps. So we'll say address of diffuse map, address of specular map, and then address of normal map. And that's it. We also need to change that for the UI shader as well. So here we're just passing a diffuse map texture, so we're just going to pass the address of diffuse map and remove the texture bit. Because now that that uniform for a sampler takes the texture map instead of a texture directly. Okay, so the next bit is going to be in probably down here, I'm guessing in load material. Yeah, so we're going to actually have to, we're going to want to acquire our resources at this point instead. So right now we have, let's see. So we've got our diffuse map here, which is where we're actually acquiring the texture. But we actually don't have our diffuse map yet. So this is for the texture itself. So actually right here is where we're going to put this. So here we're actually going to configure our sampler. So we're going to say M for material diffuse map. And we'll set the filter minify. And we're going to actually set that equal to the same thing as magnify. And we're going to set that to texture filter mode linear. Right, so we're sort of defaulting this. In fact, make this configurable. Right, so we actually are making some assumptions here that we probably shouldn't be doing. That should be configurable. But for right now, I'm okay with going ahead and hard coding that. So I'm just going to put a to-do there, and we'll come back to it. We also need our repeat. So we're actually going to do the same thing as we've done before. So we're going to set u equals v equals w equals texture repeat mode repeat. Texture repeat. There we go. So we'll go ahead and set that up, and then we'll go ahead and acquire our our resources here. So we'll say if not renderer text map acquire resources rather, and we'll go ahead and pass the address of m diffuse map. Okay, and if for some reason that fails, we need to treat that as an error. So we'll say k error, unable to acquire resources for diffuse texture map. And we'll go ahead and return. Wow, false. And we're basically going to wind up doing this same exact thing for the other maps. So I know we've got to actually, we've got a lot of repeated code here. I'm going to come back at some point and clean this up, but for now, I'm just going to go ahead and repeat myself. I hate it, but I guess I really don't need to sort of do that on camera. So I'm just going to, for expediency, copy pasta this and change names. So we'll do this again for normal map. Right there, normal map, normal texture map. Okay. And so actually, I'm going to also put this to do for each one of these maps. And I'm also going to slam in another to do. Dry for don't repeat yourself. Because we're repeating ourselves here and that sucks. So we actually really need to fix that at some point. But that is, I think that's it for load material. Let's see, what is this error that we're actually getting here? So we have our, oh right, we have to pass maps here, which we don't actually have an array to pass here. So the first thing we're actually going to have to do is gather a list of pointers to texture maps. So we are going to have a texture map pointer, and I'm just going to create this as a flat array of 3 because we know we have our diffuse, our specular, and our normal. And I'm going to go ahead and auto initialize this to the address of m diffuse map, the address of m specular is going to be the next one, and then m, or the address of m normal map. Okay, so now we can take this and pass maps there, and that should solve that error. And in destroy material now, since we are acquiring resources, we actually need to go ahead and release the resources for that as well. So we're going to do this right before we release the resources for the actual instance. So what we'll do is we'll release texture map resources, and we will render text map release resources, and we'll do the address of m diffuse map, and I'm going to go ahead and just copy pasta this line because it's a little quicker, and we'll do specular map and normal map. Because we don't want to not release those things, because obviously that is going to be bad. The next thing that we're going to have to do is in our default material creation, that is also not going to have what it needs for texture maps. So we don't actually have an array of pointers here to pass. So we're going to need to go ahead and get that as well. So we are going to need to say texture map pointer, and this is going to be maps of size 3, and we're going to auto initialize this one as well. So we're going to say the address of state default material, and then this is going to be diffuse map, And then we're just going to, I'm going to copy pasta this again because we need to do this for the specular map and then also for the normal map. And then we can go ahead and pass maps here. And that should be, I believe, all we need to do because I think we've changed all of our pointers here to use texture maps instead. So I'm going to build, and let's go ahead and run and see if we broke anything. So our terminal, so it looks like we're actually loading stuff up. Oh, okay. So we have a segmentation fault. All right, let's take a look at our call stack. Let's crank this up a little bit. So our apply instance looks like it has failed. Apply or fail. So apply instance. Did we see what it's actually bleating about here? So our internal data image. Oh, I think that's wrong for some reason. Image infos. What is the index we're on? 0. Okay. So it looks like we have a view and a sampler. What did I miss? Did we have any errors up here in loading all this stuff up? It doesn't really look like it. Okay. Before I drill into this too much further, let me actually do a clean in a build, just to make sure that nothing got missed there. Nope. Yeah, something got missed for sure. So I guess let's take a look at our changes here and see what we actually changed and what we might have broken. So our texture map looks like it's grabbing the correct texture here. Channel count 1, height 1. This doesn't look like a valid texture. Did we not somehow assign our texture pointer correctly? Yeah, the map we have here, the configuration's correct. The texture is seemingly a valid pointer. Generation is 1. Name is rubbish. Okay. I don't even know what texture this is. I wonder if this is one of our default textures. Total sampler count. We have 3. Okay, so that is configured correctly. Internal states. Bound instance ID is 1. Okay, so let's drill into this. Instance texture maps. Yeah, that doesn't look right. We only have a channel count of 1, a height of 1, and a width of 32,767. Interesting. So, did we miss something in our texture system? I think we only actually changed a couple things in here, so I can't imagine. Yeah, this was just is writeable. I can't imagine that was actually the cause of the problem. What about our shader system? So we changed that to texture map. what is missing? So we have a global texture count. We're not using even global textures, so I know it's not that, actually. Our material system. So actually, let's actually take a look real quick at... Oh, I already killed the application. Let me relaunch it. I need the call stack again. Okay. So what material is this? First off. Test material. Okay. So our test material, and this was which index again? 0. So it's failing on the diffuse. And again, I'm guessing that's because the texture itself doesn't exist. Diffuse texture. So our diffuse map in the material is wrong. Okay, so if we actually go here to our material system, what did we change? So all we're doing is passing the address of the maps here, so that actually all looks correct. So I don't think it's that. Did I forget to update something here? So we're setting the minify, the magnify, the repeat UVW. We are passing the address of the diffuse map to acquire the resources. That seems fine. We're doing the same here for the specular map. I don't think we missed any renames here. No. And besides, I don't think it's even that anyways, because it's actually tripping up on the diffuse. Okay, and when we're passing this, we have diffuse map, specular, and normal map. Then we're passing maps. That looks correct. This is just destruction. I definitely know it's not that. Create default material. Again, is just the address of the diffuse, specular, and normal maps. Just passing through maps. So I don't think it's anything in here. So I'm actually wondering if it's something in the back end that we missed. So all we did was remove this. Remove that, so it's not going to be either of those things. The view should not have actually changed, so I don't think it's that. The map, internal data, cast to a VK sampler, that looks fine. This hasn't really changed either. It's just we're looking at the texture maps now. And it's just grabbing the texture that's been assigned there. These are our conversion functions. I'm not really worried about those. Texture map acquire resources. So this is just creating the sampler. I don't think it's that either. Acquire instance resources. Maybe it's something in here. So we have our instance texture maps. We're allocating an array of texture maps times the texture count. That looks fine. Our instance texture maps is equal to maps sub I. That should be fine because it's just copying over a pointer. And then we are setting the texture to default texture. So I seriously doubt it's that either. Oh, wait a minute. That might actually... We probably should do this conditionally, actually. This should probably be if maps sub I, or if not maps sub I, texture. Right, because we only want to use the default texture if we don't actually have a texture. I could see that causing a problem. We're probably just clobbering our texture and for some reason using the default texture, which also isn't seemingly loaded correctly, but let's see if that actually fixes it first. Nope. Okay, so is it the same thing though? Yes, it is the same thing. Okay. So, let's go back. So we have our instance texture maps. This is the destruction or the release of written instance resources. So I don't think it's going to be anything in here. Set uniform. Maybe there's something in here. So all we're doing is setting the texture map at the uniform location to the texture. Oh. Oh. That's what we're doing. This is, okay. That's what we're doing. I thought this looked wrong. Okay. So whenever we're setting the uniform in the shader system, we are actually passing through the texture map. But here, all we're doing is extracting the texture out of that. So this is actually wrong. This should just be a texture map value here. So this actually was right. It was actually this one that was wrong, and I corrected it in the wrong direction. So instead of setting the texture here, we should be setting the instance texture maps to the texture map that is passed through as value. That is probably what it is. Yep. Okay. So that was a fun little excursion. Okay, so that is our texture maps fixed. So no visual update this time, but our texture maps at least are holding our samplers now, which puts us in a much better position down the road when we actually get ready to start taking a look at a material editor and things like that, because you actually want that to be bound to your texture map, not your texture itself. So this prepares us for the next step in the process, which is going to be working with creating our configurable views and our individual frame configuration, which is a precursor to what you might call a render graph. Now, it's going to be quite some time before we get to that point, but we're trying to make these things configurable via the front end. That way, at some point, we can hook up this configuration to a file or maybe an editor or something along those lines and be able to actually configure this stuff and be able to load it that way. So anyway, that is going to do it for this particular video. Thank you guys so much for watching. If you like this video, please toss it a thumbs up. If you haven't already, consider subscribing. The subscriptions help me out a lot. And don't forget to hit that little bell icon that's in the lower corner next to the subscribe button to get notifications as to when new videos in this or the other series that I have drops. And I will see you guys next time.